One of the problems facing geologists today is the fossilized tree. There are a number of examples in Australia and America and elsewhere where a fossilized tree can be seen running vertically through a number of coal seams. Here's an example from the coalfields of Birmingham in Alabama in the United States. Some of these fossilized trees, 12 meters or more in height, can be seen running through a number of banks. This model gives some idea of the situation. Now, the curious thing is that we are told that any one of these banks takes millions of years to form. Now, if this was the case, it would take millions of years to bury the tree. But that's not possible, because the tree would decompose or rot long before it was all buried. So, what is the explanation so important about those rocks? Well, they're not any old rocks. They are made mostly of tiny grains of sediment. They are called sedimentary rocks and cover 3/4 of all the land on Earth. And what's more, they were formed under the sea. When the sea level dropped and the sediments were exposed to the air, they dried out to become rocks.
Look at this cliff face. It's divided into facies, sometimes called banks or deposits. The sandstone deposit has been coloured yellow, the deposit of clay blue, and the limestone coloured orange. Each deposit or bank is subdivided into strata. These horizontal lines are strata. To understand the incredible story that this film has to tell, a closer look at the strata in the deposit is necessary. They follow a pattern. The larger particles collect together in a line at the bottom, then the smaller ones gather on top. This pattern is repeated throughout the deposit. Sometimes a break or joint can be seen between the top strata in one deposit and the bottom strata in the deposit on top. These breaks are called stratification joints or bedding plane partings.
For some time now, there's been a suspicion that these rocks contain a secret, which when discovered will change our ideas on the most important subject of all. How did mankind originate?
One of the first sedimentary rock experts was a German. His name was Johannes Walter. Whilst in Italy at the end of the last century, he examined the sediments in the Bay of Naples. He discovered, by boring vertically downwards through the sediments in the bay, that the banks that lay on top of each other were in the same sequence as those that were lying next to each other horizontally. The sequence of banks that could be seen lying side by side as he went from the coast out to the sea was the same as the sequence of banks that lay on top of each other in a downwards direction. He realized that the belief that the bank at the bottom was older than the one on top was wrong. Quite obviously, all the banks, the one at the top, the one underneath, and the one at the bottom, were all still forming. They were forming sideways, so that part of the top bank was the same age as part of the bottom bank.
It didn't take Walter very long to work out what caused the banks to form sideways.
The particles of sediment coming into the sea from rivers, floods, and wind sort themselves according to their size. These larger particles, coloured yellow, stay near to the coast. The less heavy ones, coloured blue, are washed out a little farther. Then the tiny sediments, the orange ones, are carried out by the waves and currents even farther. It can be seen that the layers of new sediment are deposited side by side. The particles of sediment in the layers sort themselves out according to their size into the banks of various types of sediment. This could be a bank of pebbles, this a bank of sandstone, and this one clay. So the banks form sideways. That part of the bank nearest the coast is older than the part of the same bank farther away from the coast. So this part of the bank at the bottom is the same age as this part of the bank at the top.
Before Johannes Walter, in 1870, two Russians, Golovkinsky and Inonstrantsiev, had noticed that in ancient ocean basins that had filled up with sediment, the same series of deposits could be seen on the surface side by side and vertically, one underneath the other. The feature of these series of deposits or facies are that they are parallel to the basin slope. Those in the Gulf of Naples, observed by Walter, are not. They are almost horizontal. The reason is that apart from small changes caused by the tides, the series of deposits in the Gulf of Naples and elsewhere result from the sea always being at the same level. The position of deposits of sediments in ocean basins, such as those observed by the two Russian scientists, would seem to be the result of major changes in the level of the ocean. Rising water level is called a transgression. Falling water level is called a regression. When the water rises or transgresses, perhaps as the result of tidal waves, the sediments deposit parallel to the sloping sides of the ocean basin. The larger yellow particles depositing next to the slope. When the water level falls or regresses, the sediments deposit with the smallest particles, colored orange, next to the slope. Looking at former ocean basins, now filled in with sediments, the position of the deposits or facies indicate that the waters of the past must have risen and fallen time after time in fast succession. As sedimentologists would say, transgressions followed by regressions seem to have occurred in cycles. The different kinds of deposit are again the result of sediment sorting itself out sideways, and not one type of deposit superposing itself upon another. It would appear, therefore, that the origin of sedimentary basins is the result of cycles of fast, rising and falling water levels, or more technically, transgressions and regressions. The position of the deposits is not, therefore, the result of the principles of superposition and continuity, but the application of the law of Johannes Walter. These cycles of rising and falling water levels couldn't have taken place all around the world at the same time. Perhaps they were like large-scale ocean tides, so that where the water level was rising and depositing massive sediments in one place, at the same time sediments were being deposited elsewhere, where the water level was dropping. The reaction of the other rock experts was that Johannes Walter's discovery only explained coastal rocks, and that deep sea sediments were always formed by a layer of sediment forming on top of another, and that the layer on top is always younger than the layer underneath. In this cliff face, probably formed from deep sea sediments, the strata in the banks at the bottom are believed to be much older than the strata up there in the top. The reason for this is that geologists believe that strata and layers are the same thing.
In the 1970s and 80s, several holes bored into the bottom of the Pacific Ocean by the Glomar Challenger vessel produced samples of sediment that showed Walter's discovery applied to the deep sea sediments just as well as coastal sediments. This meant that virtually all sedimentary rock formations in the world must have been formed in the same way.
So what does all this mean? Well, take what is considered to be the biggest, the widest, the deepest, the longest canyon in the world, the Grand Canyon in the United States. The sides of the canyon display banks, one on top of the other, from the bottom of the mile-deep canyon to the top. Each bank is said to indicate an age in geological time. Yet, what we know from Johannes Walter's discovery and the Glomar Challenger deep-sea borings indicates that parts of different banks could be the same age. Nevertheless, there were still those who found this difficult to accept. But two recent events have occurred, however, which should remove all further doubts.
In 1980, Mount St. Helens, a volcano in the United States, exploded. It flattened an extensive forest and caused a tidal wave in a large local lake. Within hours, 600 feet of sediment had formed, which dried into rocks complete with strata. As a result of the explosion, huge amounts of mud flowed through the adjacent rocks and bored a canyon over 100 feet deep and 200 feet wide.
Now, it has always been believed that strata in rocks and canyons take millions of years to form. But both these geological formations were formed within several hours.
The other event took place in a laboratory. French sedimentologist Guy Berthaud discovered two immensely important facts. The first was that sand, flowing continuously, whether in a vacuum, in the air, or in the water, sorts itself out into alternating deposits of large and small particles that look like layers but are not layers. The second vital fact emerged during the program of experiments he was directing with the State University of Colorado. Looking through the transparent sides of a large tank or flume, he studied the particles of sediment in the moving water. He observed that when the speed of the current was reduced, only the large particles of sediment were deposited. When the current was increased, microstrata started to form. So the grading of particles in strata was not just the result of layers of sediment piling up on top of each other, as had always been thought. The grading could simply be due to variations in the speed of the current when the particles were deposited. A further startling discovery was that joints or breaks between strata are the result of desiccation or drying out of sediment. It used to be thought that these joints were caused by an interruption in the supply of sediment. It was thought that the surface of the last deposited strata had hardened, and that many years later new sediments started to fall and a new strata formed on top of the old one. This theory now has to be abandoned because of two new discoveries. The first was that the underwater borings of Glomar Challenger showed that surface sediments under the sea never harden. In fact, hardening of sediments only starts 300 meters below the seabed. The only known exception is chert sediments, which even so only start hardening 100 meters below the sea bottom. The second discovery was in the laboratory. It was found that when the sea level drops and the damp sediments are exposed to the air, breaks occur between some of the strata as part of the drying out process. So these joints or breaks have nothing to do with time. These experiments, performed by a team of experts over many months under the most rigorous laboratory conditions, have been filmed and are available for all to see. They confirm the most important fact ever discovered in the history of sedimentology. Strata provide no indication of age.